Welcome to Made in Science, the official podcast of the University of Stuttgart. Here at the university, the High Performance Computing Center Stuttgart, also known as HLRS, promotes the use of state-of-the-art simulation technologies by maintaining a powerful high-performance computing infrastructure. In 2025, the latest supercomputer, called Hunter, was introduced. It has a theoretical peak performance, and now listen carefully, of 48.1 petaflops. This doubled the performance of its predecessor, while at the same time using 80% less energy at peak performance. Today, the director of the High Performance Computing Center Stuttgart, who is also the manager of the Institute of High Performance Computing, Professor Michael Resch, is our podcast guest. Professor Resch, a very warm welcome here to Made in Science.
Thanks for having me.
Looking at your website, I came across a quote from David Howarth in his book titled 1066, The Year of the Conquest. And there it says, "Besides, most people do not have to understand the whole of the social system they live under, only the bits of it that happen to affect them." Unquote. I'm wondering, how is the relation between the Norman conquest and our times in your mind going on? How did it make it on your website?
Well, the Norman conquest was something that I was interested in, so I read this book because the Norman conquest just changes the history of of England, the United Kingdom, whatever you want to call it, in the year 1066. But I took the quote as referring to science. It is part of the introduction, so it's not part of the story in a sense. It's part of the introduction, and what is interesting for me here is that as scientists, this exactly describes what we are doing. We are working on the bits and pieces that we are interested in. And that means we don't work on society as a whole, but we just work on the bits and pieces that are our expertise, the thing that we focus on. And the quote reminds me of the fact that whatever we do in science, it's part of the big picture. So every field you're working on is sort of a gear that interacts with other gears to create the social fabric.
And to dig perhaps even a little bit deeper here, on one occasion you've said, quote, "The fastest computer alone has no meaning," unquote. Can you unpack that statement for us, please?
Absolutely. When we speak about high-performance computing, we speak about a technology. And that technology has a potential. And that potential has to be sort of set free. So what our research is not so much to find out how we can get a faster system, because the peak performance is not relevant. Our duty is to turn this performance into something that is meaningful either for science or for industry or for society or for politics. That's our job.
Is there a risk in this endeavor that technology becomes, after all, an end in itself rather than a means to solving real problems?
Well, we currently see that. We see that with artificial intelligence. I'm just coming from a meeting where we discussed how we can react to the fact that artificial intelligence is not only a very useful tool, but also a very dangerous tool. And yes, we have come to the point where the compute power is high enough and the knowledge about methodology with artificial intelligence is advanced enough to create systems that are dangerous to human beings, to our society, and to our political system, by the way.
You work with systems that cost tens of millions of euros. How does that scale of responsibility shape the decisions you make day to day?
It is always with us. It is always with me. When we look at the future, the next 5 to 8 years, what we have to do is we have to carefully plan and we have to carefully justify. So that means we are permanently in a situation where we have to make decisions that have an impact far beyond the day-to-day business. And that translates into a mode of operation that is not based on what is my daily business problem, what is my probably the next month's problem. We are always focusing on the 5, 8, 10 years future. And our discussions are always about what is the cost in terms of money, but also in terms of work that we have to put into something, focus that we have to put on something, prioritization that we have to make where we say, okay, we do this, which means we cannot do other things. We have to do this in a strategic way, and that means our thinking always goes like, what is the impact? What is the impact of the impact? What is the follow-on consequences? Just to give you an example. In about the year 2015, we had to think about the year 25, 27. And understanding the technology and having a very good forecast of what is going to happen, it was very clear that we have to think about a new infrastructure in terms of building. And it took us like 5 years to go through all these planning steps and everything and calculate what is going to happen if we do this, if we build a larger building, more power consumption? What are the implications for our users? What are the financial implications? What are the implications for the budget of the state of Baden-Württemberg, for the federal government? How much European support can we get in? Do we have the right people to do this? What are the achievements for science going to be? What is the benefit for industry? This was an extremely long process, but for us, this is very normal. And when you talk about projects for typical researchers are bread and butter. For us, it's also bread and butter, but the projects are not like, oh, I would love to do that. They are more like, there is a long-term strategy. Which projects do I have to do? Which projects do I have to acquire funding for to make sure that this strategy is working? When we spoke about AI 10 years ago, and we started projects. We spoke about sustainability 12 years ago. We started projects. We said we just need to do that. And then when there is sort of a general awareness of the problem, okay, there is a lot of funding, but then you already know which projects you want to do. Where are the key questions? Where are the pain points and everything? So being a supercomputer center means that you always have to have a long-term strategy.
Taking up the word strategy and looking at Europe. Why do you think Europe underestimated the strategic importance of high-performance computing for so long? And has that changed?
Well, for Europe, the situation like 30 years ago was quite positive. There was like 3 or 4 supercomputers in Europe that were in the top 10 systems in the world. Everything was fine. Europe started to miss the train around 2002. In the year 2002, the Japanese government had installed a system that was a factor of 4 faster than any other system in the world. The US spoke of something which they called Computnik, referring to Sputnik. So they started huge programs to sort of beat the hell out of the Japanese. Then the Chinese stepped in and said, we want to be leading in all of these future technologies. And Europe took its time. Mainly because Europe is not a single entity. It is a collection of countries. And I remember we started discussions about a European HPC strategy back in 2001, 2002. And we ended up with a coherent strategy that actually also had some funding in 2017. So it takes a long time before Europe reacts. The positive thing is that Europe has a certain level of insistence, sustainability. They go for long-term strategies. So we are catching up, but for a while we actually missed the train, and that means catching up is difficult, and the European Commission is willing to take the steps necessary to catch up. But it's going to be interesting because we go through a technology change, and that means catching up. On the one hand, is relatively easy because if you change technology, everybody starts with zero. On the other hand, if you have all the processes already in place for a long time, it's easier to catch the train this time.
Now, the technological changes that you just stressed are very important to make the whole thing running. But there are also geopolitical challenges in our time, and how far do they accelerate certain developments? For instance, regarding the digital sovereignty of Europe.
When it comes to digital sovereignty, we have to have a very clear picture. Usually people speak about digital sovereignty and think about the processes that are built in Taiwan and in South Korea. But it's just the end of the line. It's just the final product. When you look at digital sovereignty in terms of which technology is available to whom, then it all starts with extreme ultraviolet laser in Germany. So without Germany, no one can build high-end processors. To manufacture these processors, you need machinery, and there's only one company in the world that can manufacture the machinery required to build high-end processors, and that's ASML in the Netherlands. So without the Netherlands, no high-end chips. And by the way, Donald Trump in his first term did know about that and put an embargo on ASML machines to make sure that those machines don't end up in China. And then the final step is to build or manufacture these processors, and that's done in South Korea and Taiwan. So the world depends on German laser, Dutch technology to build the right machinery, and then South Korean and Taiwanese technology to be able to manufacture all of this. So digital sovereignty is an illusion in a sense that no single country currently is able to build a high-end microprocessor without the support of any other country. But there is another side to this, which is the software side. That's not so important in HPC because HPC is using Linux and Linux is open source. So theoretically, you could work with Linux and you don't need any other country to work on this or give you support, or there is no company that is controlling anything like that. Europe needs to wake up and first of all understand where do we stand. What is the role that Europe currently plays? What is the role that Europe wants to play in the future? Digital sovereignty is not an end in itself. You basically need it for security reasons. We're talking about nuclear weapons here. We're talking about nuclear weapons in France and in the UK. And for the development of these systems and for ensuring the safety of these systems, you need simulation, you need high-end supercomputers. So the other question is, and that's what we have seen with the Russian attack on the Ukraine, the other question is, how much do we depend? And there, when you have a general view of the economy, it is very clear that with globalization, everything is interconnected so much that trying to be sovereign in terms of economically sovereign is impossible for any country. There is no country in the world that does not have to rely on the transportation of goods and ideas. We see this currently with the war in Iran. We see the impact that this war has on China. We see the impact it has on Europe. We see the impact that it has on the UK and other countries. Sovereignty is a term that is extremely dangerous. It gives you the impression that you are the master of everything. You can make all your decisions yourself. You don't depend on anyone. But that requires that you replicate everything that has been done so far in many, many, many other countries. And that's difficult. It's expensive. And when we look at China and we say, well, China is able to do that, we should be very careful because we see how much China depends on the rest of the world.
In the daily work of the high-performance computing center, energy plays a very important role. We've already mentioned the new supercomputer managed to work with and run with so much less energy than its predecessor. Now, is energy efficiency research a factor that also has been underestimated for some time? And is the future of computing less about raw speed and more about intelligent optimization?
What we have seen is excitement about new technology. And I do remember I had a discussion with a colleague from the US about the future and the power consumption back in about the year 2005 or 6. So that was like 20 years ago. And they were talking about what is going to happen in 10, 15 years. And we were discussing technology, and we were also discussing power consumption. And I said, yeah, okay, we aiming at this and this and this type of processor. We're talking to these companies, and we expect this to happen in 5 years, and in 8 years, and in 10 years, and something like that. And they said, yeah, okay, and first we will use like 10 megawatt, and then 20 megawatt, and then 50, and then 100. And 100 megawatt, that's a city. And I was like, how are you going to do that? And my question, how are you going to do that, was like, that's expensive. You need to have a budget. You need to take away money from other people who can do some research with that. And they looked at me and they said, oh, that's not a problem. The power supply company can do that. So for them, it was more like a technical question. Well, for me, it was a financial question and an economic question and an ethical question. Power consumption of 100 megawatt is more than, I think, like 12 or 15 African countries have as a power consumption, each individually. So you're consuming more power than these 5 million people or 10 million people living in one of these smaller African countries. But the hype, the excitement about new technology was such that actually nobody was looking at power consumption. And I do remember a lot of discussions when I was giving presentations in international workshops, and people asked me, so what are you going to do about power consumption? Because you will also need 10 megawatt and 20 megawatt. And my consistent statement was, we will never go beyond 5 to 7 megawatt. We will never do that because there is no justification to spend that amount of power and that amount of money for a system that gives you probably a factor of 2, which, yes, helps to improve the quality of your science. But I don't think it is justified. So, yeah, we were looking into this a long time ago, and we were looking into this not from a technical point of view. Yes, you have to do that, but much more from an economical point of view and from an ethical point of view. You have to justify how you spend that amount of money.
Taking up the issue of energy, but on a personal level. Let's find out how Michael Resch, the human being, the student whom he was once, perhaps the pupil, depending how far back you want to look at this moment, how would you describe your career as a result of deliberate planning, or something closer to following something else, more curiosity, whatever was the case? And how did you manage your energy level?
That's a good question. That's a very good question. Now, as I just said, we have a strategic planning for long-term strategies. That's perhaps my own personality also. When I had to make a decision which field to study, where to focus on, the purpose of me studying technical mathematics was to change the world. I didn't have a short-term strategy in terms of finish the studies, make money, and work for this or that company. The focus was change the world. And what happened then was a combination of hard work, probably genetically positive disposition for being curious, and luck. Yeah. So during my studies, during an exam actually, it was like 10 minutes of questions, and then the professor looked at me and said, okay, I know you know everything. Would you like to work for me? I was like, okay, I need to think about that. And this is how my sort of career started. And so I worked as a research assistant, and the piece of luck was that my professor actually said, he's a student, but he's clever. So he let me come up with my own ideas, and he put my name on journal papers and everything, because he said, this is a valuable contribution. And at a certain point in time, he was fair enough to say, by the way, you also have to finish your studies. And I was like, okay, let's finish this journal paper. It took like 6 months, and then after that, I'll finish my studies. And then I moved to industry because I said, well, this scientific career is probably too narrow. And by accident, I was talking to colleagues who were working in a company that was doing groundwater simulation. And that was something that resonated with me, because I had done blood flow simulation, which helps people. Groundwater simulation helps the environment. That was sort of, yeah, okay, I can have an impact. And I went for that for 2 years. It was nice work. Didn't think too much about my scientific career. In the back of my head, I was like, I probably should go for a PhD. Until I figured the business world is a world where you not only take your private decisions, but sometimes you have to follow the customer in a way that you don't approve of, and where you probably get into ethical conflicts. So I decided to go back to science. And at the time, Austria was a nice country, wonderful place to go on vacation, but not a perfect place to work on supercomputing. So I decided to leave the country. I went to Stuttgart, was working there, doing a lot of projects, writing papers. Everything was fine until my boss said, by the way, you should finish your PhD. And I was like, yeah, okay, when do you want to have it? And he said something like, could we have it in June? That was November, and my first kid was just born. And so I was like, well, let's make this faster, because when a kid grows, starts to scream. Okay, so let's finish that by March. And I just finished my PhD by March. And then my director was about to retire. So he told me, you cannot be my successor, so you better move. So I said, okay, if I have to move, then yeah, I have to move. So I got these 2 offers from companies, and I had these 2 contracts, and I was like, okay, let's think about it a little bit. And I was going to a conference in the US. And I said to my wife, when I come back, I'll make a decision. And during that conference, a friend came to me and said, Michael, we're looking for professors at the University of Houston. And I was like, another piece of luck. I said, okay, let's do that. I went back home, told my wife, not working for industry, we moved to Houston. So, was there some kind of planning? Yes, the plan was to make a contribution, sort of make the world a better place, do it based on mathematics, using computers and everything. But there was never a plan to become the professor or the director of a supercomputing center. I went to Houston, nice place to be, researchers, projects and everything. And the University of Stuttgart said, would you mind coming back? And I was like, okay, I just moved to Houston. I mean, you take your family with you. My first son was born in Houston and everything. So, yeah, that's how it all worked out, more or less.
More or less.
Hard work,
yes,
luck, and curiosity.
Yeah, and for the energy that you by now kind of avoided answering. I'm still interested in
Energy was always on my mind. I mean, I do remember we had, during our studies at the Technical University of Graz, we had these intensive discussions, and we were thinking about having electrical cars and everything and moving to clean energy. And I do remember we did a lot of projects then also at the University of Stuttgart at the time when I was working on my PhD. So energy, in a sense that it's part of the climate problem, which we identified, or I had seen in discussions in 1986, I think so. Energy, climate change was always on my agenda. That was important. When we had our first new computer room built in 2002, the idea was to reduce the power consumption, reduce the cooling costs and everything. And at that time, I remember we were fighting with the state of Baden-Württemberg whether this is legal or illegal, because from the point of view of the state of Baden-Württemberg, this was about you want to have some additional facilities to cool. And the Landesbauordnung at that point said, no, cooling is not good because it's sort of luxury. And we said, that's not luxury. You're reducing the costs of running a supercomputer. You're reducing CO2 footprint. And so that was at times difficult, but we pushed for that. And one of the main driving forces is we're short on money. We're always short on money. So energy is cost. So if you want to push people, you don't let them know that you're saving the climate or anything like that. You let them know that they have to pay for it. And then they look at you and say, can you reduce that? And you say, yeah, we can, if you allow me. I reduce your costs. Well, that reduces CO2 emissions. That's great. It's a win-win situation.
And your approach seems also to be rather showing and only some telling. I mention this because you have been very successful bringing politicians and industry partners directly to the center, showing them the work firsthand and the impact. Why did you consider that so essential rather than simply publishing the results?
Well, I'm probably a bad scientist. Yeah. Because in the US, and also during my studies when I was working for the professor, it was very clear, publish or perish. You need to publish, you need to publish, you need to publish. And it's absolutely clear, and I fully understand that you go into the discussion with your colleagues and you get this scientific visibility. But when you're a supercomputing center, what you have to do is you have to justify what you're doing. People have to understand what you're doing. You have to make clear that if the state provides you with like 50 million euro and the federal government provides you with a 50 million euro budget, you are sort of in a competition. Yeah, you could invest the money into some hospital or some kindergarten or things like that. So my idea was always to not try to convince people by writing more papers, but try to convince them by showing them what's happening and discussing with them what their needs are. And that's, I do remember my first meeting with a big car manufacturer here in Stuttgart. And he looked at me and said, "We don't need that." I said, "It's okay. Let's stay in touch. I will just show you what's possible." It would not have made much sense to say, "But yeah, we are great and we have a lot of publications and blah, 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 and we're a leading center in the world and blah, blah, blah. Please work with me." I said, they need to understand, they need to see. And actually we invited them to come and look, and they came and said, okay, maybe a nice presentation by 2 or 3 scientists about what we can do in flow simulation, material science and things like that. And the good thing was that the university itself is very close to industry, so that was relatively easy. With politics, it was a bit more complicated because from the point of view of politics, science is important, but it's also a cost factor. And the traditional meeting between a professor and a politician is, can I give him more money? And the politician saying, I will do my best, and the scientist, but I need more than that, and blah, blah, blah. And I thought that's not such a good idea. So I got this chance when the state of Baden-Württemberg had this Übermorgenmacher-Preis.
The Tomorrow's Makers, yes, 2012.
The day after tomorrow makers.
Yeah.
And the award was that I had a wish. And there was a limit. The limit was the wish must not be more expensive than €1,000. And I said, my wish is that the Minister of Science at that time, it was Mrs. Bauer, just come to the center and talk to us. And she came, and politicians, my uncle was a high-level politician in Austrian politics. So I know what their schedule is. Get up at like 5 o'clock in the morning, drive to some place, meet, greet, grab a little food in between, meet, greet, and you get bored. And everybody is talking to you, please give me. So I said, the only thing we want is that Minister Bauer understand what we're doing. And judge herself. Is that relevant? Is that important? And so I said, we don't give her the usual presentation. It's not going to be me who gives the presentation. It's the young researchers who are working on these problems of what do we want to change? Where do we want to go to in the future? And it worked out extremely well. She left with a smile. And from then on, it was clear to me that these things actually work out. And then you have this word of mouth that goes around, and I was there, you should go there and see it. So at some point, we ended up with politicians asking us whether they could visit us, and that's just great. And that goes back to one of my strategies that I developed as a child. I grew up in the mountains, so you have these small rivers, and you can play with these small rivers. And everybody was trying to build the most impressive pool. So you sort of try to hold back the water. But the water keeps flowing, so it's difficult to build the dam. And I figured the easiest way to build a large pool is to build the pool first, and then reroute the water. And so I figured if you start upstream with a very small intervention, the water flows into the right direction. And this is how I work in these fields, where I say, it doesn't make sense to say, please, everybody come to me and then give this presentation and tell everybody how important you are. It's the small things that you have to change. It's the small things where you say, why don't you visit us? Would you be interested in that? Or let me show you what we've done. And these small things then have a huge impact. So you start with small things because you know that in 10 years from now, you will need that. And if you do that, things work out the way you want. And in the state of Baden-Württemberg, the great thing is that we have politicians in each of the political parties who understand how important science is, who understand how important it is to have the right research infrastructure.
Now, you're a communicator, obviously. It seems to me that you also use art as a way of communication at the center. When I visited it the very first time some years ago, I noticed that immediately. And I think I didn't expect it to be at the center. What is your thinking behind putting art in the building, in the open spaces, just outside of the building?
Well, there is a sort of a mentality that is a bit Austrian, probably, and I also see it in Italy. That is that art is nothing special. It's a piece of life. It's an expression of thoughts and feelings. It's an interaction. It's a nice part of your life, regardless of whether this is theater or paintings or movies or photographs or music or whatever. And so my first approach was to say, we need to keep this part of life also in our working environment. And now the good thing is that there is this requirement that I think like 0.5% of the money you spend for a building has to go into art. And I was like, that gives us a potential, not to just say, okay, someone decides that some artist should put a piece of art in front of the building, but rather integrate it into the building. Turn it into something which is relevant for the people who work in the building and see it every day and communicate with it. And we were pretty lucky because the architect of our first building was Michael Held, who was himself very much interested in turning his buildings into pieces of art. And he was working with Harald Müller. And so we had this first court in HLRS, which is a Japanese woodcut. And we went to the second court in the second phase, and we said, okay, we have worked a lot with Japanese, we also work a lot with the US. So Harald suggested that we sort of have a citation of a piece of art that was done in the US at the time. And then the third court that we built in 2017, I said, in our simulations, we're moving towards quantum computing, towards non-deterministic, sort of accidental things, probabilistic things. And since I'm interested myself in art, I was aware of a project, a concept by Mallarmé, which is called Le Coup d'Été. And I said, Harald, why don't we do a coup d'etat? And so Harald came like 2 weeks later and he said, I've done a first attempt and this is what it looks like, but it would be nice to probably rearrange this such people feel better with the piece of art. And I said, no, that's what we're talking about. I mean, you just threw like 10 dices and that's what you look like. And that's accident. Yeah. And that's how we then actually built it. We didn't change anything. And so art was for me important because it is part of the life of people. People communicate with art. And then later on, I came across a German philosopher, Ernst Cassirer, who had written a book about what he calls symbolic forms, symbolische Formen. And Ernst Cassirer says that you have different symbolic systems that allow you to describe and understand your world. Science is one of them. Art is another one of them. Religion is another one of them. And I figured, that's what I had in my mind without being able to express it. Art allows you to understand reality as much as science allows you to understand reality. And we're talking about the same reality, just is a bad word here probably. Yeah? Just that you have different symbolic systems that allow you to describe that. Now, I wouldn't throw away my supercomputer for a piece of art and then hope that that piece of art can help me to predict the climate. But it opens your mind to understanding that as a scientist, you have to change your point of view from time to time. There is this very famous book about the revolution in science by Thomas Kuhn. And what he describes is that from time to time there is this revolution, and then like decades on, the only thing you do is you accept that revolution and you work with that, and you're not innovative in a sense. You're more like adding some small pieces to that revolutionary approach. Now, what art does is it forces you to rethink your perception of reality. And that keeps your mind alive. And you don't get stuck with doing the same for the next 30 years or so. Yeah? So I see art now as sort of an inspiration, not in a way that we see it sometimes in, okay, we're using this piece of art, it could be turned into a product. Yeah? But rather in the sense of rethink, stop thinking in what you have done for the last 30 years, reshape everything, restructure it, and then looking at a painting. That's fantastic. You look at that and you say, that's what he's doing or she's doing, yeah. I think it's a great source of inspiration for a scientist.
And I think in an increasingly technological environment that we are living in, this may also be what keeps us genuinely human.
Well, yes. My personal interpretation of Ernst Cassirer is that these different symbolic ways of describing the world are not something that we created as formal systems, but something that we created as expressions of our being human. And that you get stuck if you decide to go with only one of the symbolic descriptions because it limits you. Huh? But I'm always very cautious when I'm in discussions with the general public about science being so non-human. We should not say that science is non-human. It's very human. Curiosity is very human. Trying to find a way to fix that problem is very human. But going that very formalized way, you limit your creativity. And so, it gives you more humanity in a sense.
Let's expand. Well, we have a couple of more questions.
Okay, go ahead.
And actually, they follow a formula that has been very well established here with us at Made in Science. It's called Moment 7.
Okay.
These are 7 questions, and we would like to ask you to answer them very briefly.
Okay, that's difficult for me. It's really hard.
I know that you accept any challenge. And here we go.
Okay.
Moment 1. Spätzle or Maultaschen?
Maultaschen, roasted.
Moment 2. One thing you could change about the world would be?
Oh, come on.
One thing only. Not the whole world.
Nothing.
Moment 3. Do you have a recommendation for a book or a music, a movie, theater, museum visit?
Book. Read The Process by Kafka.
Moment 4. The best advice that you have ever received was?
It was by my aunt. And I was wondering whether I should accept the offer of my professor to become a research assistant. And she said, if he thinks you're the right person, then you shouldn't have any doubt.
Moment 5. Your favorite place at the University of Stuttgart is?
It's most likely my office, because I meet so many people there. Yeah.
Moment 6. Please complete the sentence. If I could start all over again, I would do the following differently.
Nothing.
And finally, moment 7. Also to complete a sentence. Thanks to my studies, I know that...
Thanks to my studies, I know that we are constantly struggling and we will never find a final solution.
Professor Resch, once again, thanks for having visited us today here at the podcast studio, and wishing you and everybody at the center everything, biggest success possible in the future.
Let me thank you for having this interview. One of the reasons I love to be at the university, one of the reasons I don't care about the places, is that we have so many great people here. 2 of them are here in the room with me today. Thank you.
We do appreciate that, Christina Fischer and myself. Thank you. And to our audience, please stay also tuned for our next conversations that are always based on what is made in science. Thanks for having joined us today. My name is Wolfgang Holtkamp. Have a great podcast day. Goodbye and good talking.